All right, moving on to our next graded activity. If we go ahead in our Google Classroom, hit graded activities, that'll take you here. We just covered this video. We're now going to go ahead and look at this Greenland presentation, which was actually very similar to the sea level presentation. They kind of went together. So if we go to sea level presentation, Greenland presentation, you're going to go to week 3, linear functions. So week 3, linear functions, Greenland final learning, and you're going to hit, the document is titled 11.20 ice of loss activity. This kind of went together with the activity up above here. So we're going to go ahead and click that document, and you're going to see how this is going to look like. Now there's a part that we did in class, and there's a part that you're also going to do. So let me open up that file. And here it is. So according to NASA, this is the land ice. This is Greenland. You can see that it's steadily decreasing, right? It's got a trend. It's not constant again, because constant would mean that it has to decrease by the same amount every time. And we're not seeing that because it does kind of deviate. You know, maybe some explanations could be that temperatures, right? You know, in the warmer climate areas, maybe, you know, it's decreasing. Maybe it's snowing, so the ice is increasing and then it's melting. You know, it's something or to that extent. Or you can even look up things if you want to find some more stuff. But nonetheless, here they just didn't have data. So don't look at this breaking point as something weird. It's just they didn't have data. So there it is. Now, this is how much gigatons. This right here represents gigatons. So I'm gonna write gigatons right here. Gigatons of ice being lost. In case you're curious, 3 gigatons of ice lost is this much water in Manhattan, New York, which is kind of insane when you think about it. That means we're losing thousands of ice mass, Greenland mass, right? We're losing so much that's being poured into the ocean, which is one of the reasons for why we have a sea level rise. So they kind of went together. So here it is. So we kind of went ahead and labeled it right here. 1 gigaton is equal to 2.2 trillion pounds, by the way, which is pretty crazy. And this is the data from 2004. So starting in 2004 all the way to 2008, where we're taking this data here and we're going to try to make some predictions, right, into the future, right? Always trying to make predictions. And notice this is how much it's going down by. Now, is the Greenland ice melting at a constant rate? Well, graphically, you can already tell it doesn't. How do you figure this out? Well, they're both negative numbers. So I'm going to go to Google Calculator real quick. And you can just subtract these. Now, because they're negative numbers, it can get kind of confusing, but you know, we'll do our best. Negative 583 subtracted by negative 384. And it's not letting me, shucks. Okay. You know, that might be a little too confusing since they're all negative, right? Because it's decreasing, right? That's how much we're losing. Since these are negative, what we can do, all right, is we can just ignore the negatives for now and just do 543 minus 384, right? So 543 minus 384. So we know negative 384 subtracted by 159. All right, hopefully that made sense. You know, is going to give you this number down here, right? Instead of adding, we're subtracting. So now we're going to do this next one, 798 minus 543. So 798 minus 543, and that's 255. So this is minus 255 right here. So you can already tell. I'm going to stop. These two numbers are not the same. It's not decreasing by the same amount, so it's not at a constant rate. So you can see right here, we've explained that the Greenland ice, its first year, it loses 159. From 2016 to 2015, it loses 255 gigatons of ice. It is not melting at a constant rate. Now we want to predict what's going to happen in 2020. And I already did the work for you because it's very similar to the other one that we did. So how do we make the equations? Or sorry, let me go back. We want to predict what's going to happen in 2020. So what are we going to do? We're going to make our own table modeling constant rate. Now notice how this goes 3, 5, 7, 1,000, 1,300. So what I did is I decided to subtract by 200 every time. So you're going to see that I chose a constant rate of 200 just because for me, I felt like that is what made the most sense, right? In me personally. So I subtracted by 200 every time. That's what I chose, right? Again, I just chose something that was fair. So what's our equation? Y equals negative 384, right? This is our starting value. And then we're always subtracting by 200, so minus 200x. Now, what is the projected ice loss in 2020? This is tricky, right? You might be wondering, where does 16 come from? Well, remember, we started in 2004, right? This 2004 is coming from this number right here, right? This is our starting value. We want to know what's it going to be in 2020. Well, how many years have passed by from 2004 to 2020? 16 years. So in this case, right, it's been 16 years. So we're going to put the 16 in here. We're going to multiply these two and then use our Google calculator. And we get that we have lost 3,584 gigatons of ice. Now, that is our prediction. According to this, by 2020, we will have lost 3,584 gigatons of ice. Well, if you actually look at the data, it's actually closer to 5,000. So you can see I was, again, in both estimates, I was underestimating it. Man, that was tough. Gosh darn it. Maybe not the best. So now what you need to do is you need to come in and you need to decide, well, what are you going to choose? I did subtracting by 200. So you probably need to do something bigger, right? Because you want your estimate to come out closer to 5,000. So, you know, someone in class recommended minus 300. Well, I'm going to say this right now. I don't want you to do 300. You can do anything else that you want. Maybe you want to do 320, maybe 350, maybe 370. Totally up to you to decide. Again, the power is in your hands, but you're not allowed to choose 300, right? Because that's what we did in class. So I want you to choose something different. And you're going to fill out the same thing as before. You're going to do your negative constant rate and what is a projected, and then is your estimate a better one. And then when you're done, make a video explaining the work that you did, and then go ahead and send it over or request a session for us to meet. So this is your next graded activity. Go ahead and finish this up.